Welcome to The Explainer. Today, we're diving into the hidden chemistry that actually stops your dental fillings from falling out.
So how do crowns stay put? Gluing organic resin to inorganic porcelain in your soaking wet mouth is insanely tough.
Enter our chemical hero, Silane. Think of it as a microscopic bridge, the ultimate glue for your dental repairs.
Why silicon instead of carbon? Well, silicon has a vacant 3D orbital, making it super reactive for forming strong bonds.
A functional silane acts kind of like a bilingual mediator. It literally holds hands with both the resin and the tooth. But to work its magic, silane needs a quick jump start from acid and water through a process called hydrolysis.
Water attacks the silicon atom from behind, briefly creating this wild, super unstable trigonal bipyramidal transition state.
Molecular size totally matters here. Bulky groups act like massive shields, creating steric repulsion that drastically slows water's attack.
Now, silane needs a rough canvas to really grip, so we pre-treat the surface to boost its silica content.
Dental labs use grit blasting or acid etching to carve out microscopic pits, giving the silane something to grab onto. Advanced methods actually heat silicon nitride to extreme temperatures, forging a 3D silica network for maximum rock-solid grip.
Another crazy technique literally burns silicone gel at high heat, thermally oxidizing it into a flawless layer of pure silica.
Once prepped, silane bonds fiercely to silica and glass. It forms incredibly tough siloxane linkages that lock everything together.
Hit it with that dentist's blue light, and free radicals react with resin monomers, sealing the final chemical handshake.
This exact microscopic chemistry is what keeps your ceramic repairs, reinforced posts, and even titanium implants securely in place.
But remember, your mouth is a hostile, soaking wet environment. Over time, water gradually degrades those vital siloxane bonds. To fight that decay, chemists deploy cross-linking silanes. They form a dense, 3D shield that completely blocks water diffusion.
This brilliant cross-linked network takes way more energy to break down, which massively improves your filling's overall lifespan.
Researchers are even synthesizing highly hydrophobic long-chain silanes now, repelling water further to relentlessly protect against that bond degradation.
So with these crazy nanotech advancements, will tomorrow's chemical bridges finally outlast the very teeth they were designed to repair?